Number one is alkanols. Alkanols are alcohol that is OH bond bonded to hydrocarbon. As we having is IUPAC name is ethanol, but there is one more nomenclature for these compounds, and we used to call them carbinol. So this I should say, either this is methyl carbinol or this is called ethanol. IUPAC name is ethanol. So we are having different categories in which on the basis of the carbon to which that OH is bonded, they are called primary, secondary and tertiary alcohols. This is primary alcohol as is bonded to the primary carbon. This is secondary alcohol. Bonded to secondary carbon. And this is tertiary alcohol. These alcohols, they are thought to possess the active hydrogen, and the decreasing order of active hydrogen is that this having the most active hydrogen, followed by this, then is this. So this is the decreasing order of the acidic or active nature. Decreasing order of active hydrogen. The tertiary alcohol, which having least active hydrogen, is thought to be the one having fastest COH bond cleavage. तो अगर COH बॉन्ड क्लीवेज की बात करें तो COH बॉन्ड क्लीवेज का ऑर्डर यहाँ से यहाँ कुछ ऐसा होगा. the one who having the least active hydrogen is the one who having or who is order of Arrhenius base. Arrhenius base is the one who give OH negative. Yes or no? तो भैया जिसके एक्टिव हाइड्रोजन सबसे लीस्ट है वो आर्हीनियस बेस सबसे स्ट्रॉन्गेस्ट है. कोई कंफ्यूजन इसमें? द सेकेंड कैटेगरी ऑफ अल्कोहल इज benzyl alcohol. Benzyl alcohol is also aliphatic alcohol. Because here, similar to the alkanols, the OH is bonded to the sp3 hybridized carbon. Yes or no? जैसे अल्काइल अल्कोहल प्राइमरी सेकेंडरी टर्शरी था, बेंजाइल अल्कोहल भी प्राइमरी सेकेंडरी टर्शरी हो सकता है. जिस तरह से बेंजाइल अल्कोहल है ऐसा ही होता है एलाइल अल्कोहल. ये बेंजाइल अल्कोहल, ये एलाइल अल्कोहल वैसे हैं जैसे कि एलाइल हैलोजन या बेंजाइल हैलोजन होते थे. एलाइल ग्रुप वी ऑल नो is CH2 double bond CH single bond CH2OH. तो अगर हम बात करें तो ये जो अल्कोहल्स हैं, चाहे वो एल्केनोल्स हैं, चाहे ये वाले अल्कोहल हैं, दिस ऑल अल्कोहल हैविंग OH bonded to sp3 hybridized carbon. OH bonded to sp3 hybridized carbon. And if we see the vinyl alcohol and aryl alcohol, vinyl group is CH2 double bond CHOH and is the alcohol where OH is bonded to sp2 hybridized carbon. The same category is aryl alcohol, which are called phenols. In this aryl alcohol, the hydroxide is bonded to sp2 hybridized carbon, similar to vinyl alcohol. So that in all cases which we did, that is this, and we did this one also, alkanols or carbenols. It's very clear from here that The carbon to which OH is bonded is sp3 hybridized. This is sp3 hybridized. This is sp3 hybridized. So we are having two categories of alcohol, as we are having mainly two category of alkyl halides. One was aryl and vinyl, and the another was rest of the alkyl benzyl or alkyl halogens. Here this oxygen is sp2 hybridized. Thus this do have minus I as well as plus R effect, where plus R is dominating. This is the one where we have plus R dominating over minus I, which clearly means that here the COH bond is single bond. In case of all this category, they are single bonds. And this bond length is more. But if we see here in these cases, make the resonating structures. Because OH shows plus R as well as minus I. तो ऑब्वियस सी बात हुई कि भाई इस रेजोनेंस की वजह से जो ये COH बॉन्ड है, COH बॉन्ड है, ये COH बॉन्ड डबल बॉन्ड करैक्टर एक्वायर कर लेता है, यस और नो? जबकि ये COH बॉन्ड हमेशा सिंगल बॉन्ड रहेगा। इसलिए इन दोनों में फर्क आ जाता है कि ये बॉन्ड लेंथ जहां 141 पिकोमीटर होती है, वहीं ये बॉन्ड लेंथ 136 पिकोमीटर होती है। ने बता दिया कि COH बॉन्ड यहां स्ट्रॉन्गर बॉन्ड है, COH बॉन्ड यहां लेबाइल बॉन्ड है। लेबाइल मीन्स जिसको तोड़ना मुश्किल ना हो, और यहां उसको तोड़ना मुश्किल है, यस सर? अब इस बेसिस पर कि वहां मोनोहाइड्रिक हैं या डाईहाइड्रिक हैं, अल्केनोल्स में हम लिखते रहते हैं कि ये तो मोनोहाइड्रिक है। मोनोहाइड्रिक मतलब जिसमें एक हाइड्रोक्साइड है। दिस इज डाईहाइड्रिक अल्कोहल जिसमें दो हाइड्रोक्साइड है, एंड द कॉमन नेम इज ग्लाइकॉल। दिस इज ट्राईहाइड्रिक अल्कोहल in which they are present 3 OH groups. More the number of OH groups, more is hydrogen bonding, and hence more is viscosity. That's why we used to say that glycerol is more viscous than glycol. So viscosity is directly proportional to force of interaction. So as in glycerol they present more hydrogen bonding, so we should say viscosity of glycerol is more than that of glycol. Any confusion up to here? Then on the basis of aryl alcohol or phenol, we having different categories, And those different categories are as follow. Similar to aliphatic, aromatic alcohol can be dihydric, or it may have substituted groups, as we should say this is OH, and if I put here methyl, this is called paracresol. This is called paracresol. And it having position isomer, where after para we can have orthocresol. Then we having metacresol. So this is ortho position, so is called orthocresol. This is meta position, so is called metacresol. Yes or no? And then we do have the dihydric aromatic alcohols. We having orthohydroxyphenol. We do have parahydroxyphenol. And having metahydroxyphenol. We do have the trihydric alcohols or trihydric phenols. As follow. So we having this. This is called, yes, this is called catechol. Catechol is used in stabilizing the conjugate base of boric acid. So boric acid ordinarily cannot be titrated with NaOH, but if boric acid mixed with catechol can be titrated because catechol increases the conjugate base stability. Then we having hydroquinone. Then we having this is hydroquinone. This is resorcinol. हाइड्रोक्विनोल को आप रिजेंबल कर सकते हो हाइड्रोक्विनोन के साथ, जो टॉटोमेरिक फॉर्म में एग्जिस्ट नहीं करता. देन वी हैविंग द Trihydric. One we having this. 1, 2, 3. And this is called pyrogallol. If this is at alternate positions, that is one here, one here, and one here, then this is called fluoroglucinol. However, its trihydric alcohol can be like this. 1, 2, 4. And this is called hydroxyquinol. This is hydroxyquinol. So these are the different categories of alcohol. May be aliphatic, may be aromatic. Now is physical properties. Physical properties. If we take into account the physical properties and compare the two categories of alcohol, then we do have CH3OH in which the oxygen, like water, is sp3 hybridized with hybrid orbital 4 with atomic orbital 2 with lone pair 2. So having distorted tetrahedral geometry, like water, but one thing important is that this COH bond length is 141 picometer. Yes or no? And this way COH bond will always be single bond. Yes or no? And most importantly, bond angle is around 108, that is greater than the bond angle of water. In water we apply the Weisser theory, which indicates that if the side atom is smaller like hydrogen, for every lone pair the bond angle will decrease by 2.5 degree. So in water the bond angle is 104.5 degree. Yes or no? Clear हो गया? But if we see, as when these alkyl groups will increase, this bond angle will also increase. So in case of ethanol, this bond angle is around 109 degree. It means more the alkyl group is, more will be the bond angle. Yes or no? Whereas in case of aromatic alcohol, O is sp2 hybridized because it shows resonance is sp2 hybridized with the distorted trigonal planar geometry. This bond length is 136 picometer, which is because of the resonance. Yes or no? And hence the cleavage of COH bond is difficult. Yes or no? The second important thing about this is that this CH3 group shows plus I effect. When this CH3 group shows plus I effect, OCOH bond dipole increases. But we know that the carbon here is sp2 hybridized, and sp2 hybridized carbon cannot show that much electron releasing effect as is shown by sp3, and more precisely here the ring shows minus R effect. Ring shows minus R effect, and because of this reason dipole moment of phenol is less than that of methanol. That is, the aromatic alcohols are less polar than the aliphatic alcohol. That's why the dipole moment of phenol is less than the dipole moment of methanol, as the dipole moment value in methanol, the dipole moment is 1.71 dBi, whereas in case of phenol it is 1.45 dBi. Yes, no. And the reason is very much crystal clear, that OH is bonded to sp3 hybridized carbon. So we should say that the dipole moment of aliphatic is more than that of aromatic. Yes or no? Next physical property is solubility. Solubility in water. The lower alcohols, they are water soluble. Lower alcohols are water soluble. But as we move towards higher alcohol, the solubility decreases. The reason is here. We having alcohol CH3OH when come in contact with water, who is bent in shape, but the H of water and O of alcohol shows hydrogen bonding. So, due to this reason, this alcohol having two parts. One is this, another is this. This side is called water heating side. This end is called hydrophobic end. And the one where hydrogen bonding is taking place, that end is called hydrophilic. So this is hydrophilic. Philia is loving. So this is water loving side. As we move towards higher alcohols, this methyl will be substituted by ethyl group. We move towards higher alcohol. This ethyl will be substituted by propyl group. So as we are moving from here to here, the hydrophobic end is same. Am I right? No. The hydrophilic end is same. But the hydrophobic end is increasing. मिथेनॉल से इथेनॉल गए, ऐसा हो गया. इथेनॉल से प्रोपेनॉल गए और बढ़ गया. It means as we are moving towards higher alcohols, the hydrophobic end is increasing. But hydrophilic end remain same. It means I should say methanol is more soluble in water than ethanol. और उसकी solubility water में complete नहीं है. We have done that in solution chapter, and the name of the topic was that alcohol when mixed with water shows positive deviation. It means if we arrange these alcohols, this is their decreasing order of solubility. Methanol is more water soluble. मैं ये कह रहा हूं कि complete solubility नहीं है. Then ethanol, then propanol. And this is the decreasing order of their solubility. But when the branching will increase, the solubility trend will be different. More is the branching, less is the surface area. And less the surface area means less is the dominance of hydrophobic end. So that if you ask me, arrange in the decreasing order of solubility, so I should say that the isomeric tertiary alcohol will be more soluble than isomeric secondary alcohol, which is more soluble than the isomeric normal butanol. And this decreasing order of solubility is because that the straight chain hydrocarbon having more hydrophobic nature means is with less solubility. So this is the decreasing order of solubility. Because the branching hydrocarbon chain will be with weaker van der Waals force due to smaller surface area. Yes or no? But if it is secondary alcohol, then the surface area increases. And hence, in that case, the van der Waals force will be more, so solubility will be less, dominance of hydrophobic end will be more, and hence I should say the decreasing order of solubility is tertiary alcohol, secondary alcohol and primary alcohol. And it is due to this hydrogen bonding that alcohol having boiling point higher than the one which we finished, haloalkane. So I should say haloalkane isomeric जब हैं, they will have lower boiling point than isomeric alcohol, and this all is because of the reason that alcohol shows hydrogen bonding. This is important, and we said this is because of the hydrogen bonding. Is it okay? So this is all about the physical properties, and let us come to the method of preparation now. Method of preparation of alcohol. Method of preparation of alcohol. First is aliphatic alcohol की बात करेंगे हम. This is, so the first method of preparation. See, we have done so many things for the preparation of alcohol already. We treated Grignard reagent with formaldehyde. We got primary alcohol, we did in the previous lectures. We treated acetaldehyde with Grignard reagent, we got secondary aliphatic alcohol. We treated that with acetone, we got tertiary alcohol. So we complete the following reaction. followed by hydrolysis. What will the product of this reaction? So here we got it. What? Grignard reagent. And Grignard reagent is an organometallic compound. Although this bond is inert bond, but not inert for any metal, as metal itself is very reactive. So it is phenyl magnesium bromide. This phenyl magnesium bromide, what it will give when you will treat it with acid halide? Yes, no. And what it will give when we will treat it with ester? पूरा रहना तो आगे indication. You did this. What is the nature of reaction of acid derivatives? Yes, we did it. What was the nature of the reaction? Yes, Mr. Bhikta. Mr. Krish. No one is there. Bhagya wo. The nature of reaction was nucleophilic substitution. So that when this bond will cleave, this will cleave from here. Leaving negative charge here and positive charge here. This positive will attack here and this negative will attack here. So if we do it stepwise, we get it. This, O negative, MgBr positive. Yes or no? And this is Cl and this is another phenyl ring. Is it okay? So this negative charge will go here and hence Cl will go out. Yes or no? So that we will lose MgCl and MgBr. And let us do the hydrolysis in next step. In this step we will be getting diphenyl ketone. Yes or no? No? Yes or no? So we will be getting this is it not? Although they are less reactive, but we are having phenyl magnesium bromide. The one thing which you should always take care of is that this should be in excess. Yes, sir. That is, you having one more phenyl, magnesium, bromide. हालांकि जो रिंग यहां है इसका माइनस आर इफेक्ट है या प्लस आर है. दिस इज प्लस आर. इसलिए उस सी के ऊपर अटैक करने से ये सबको रोकता है. बट दिस फिनाइल इज अ वेरी स्ट्रॉन्ग न्यूक्लियोफाइल. C6H5 नेगेटिव किसका कॉन्जुगेट बेस है? बेंजीन का, जो एसिड है ही नहीं. इसलिए जैसे ही ये बॉन्ड इधर शिफ्ट हुआ, ये इसको बैलेंस कर देते हैं. बट दिस बीइंग अ स्ट्रॉन्ग न्यूक्लियोफाइल अटैक हियर, we used to get this CO negative, MgBr positive. We used to get this and this. But now there will not be any substitution possible, as we don't have the good living group. So here it is reaction of ketone and carbonyl compound undergo nucleophilic addition reactions. It means when you will hydrolyze it, you will get definitely triphenylphenol, which is aliphatic phenol, as the carbon to which OH is bonded is sp3 hybridized. So this is one of the path we prepared alcohol from Grignard reagent. We have already done this reaction. So the next reaction is, the second part is, that is acidic hydration. Acidic hydration occurs with dilute H2SO4 through the mechanism given below. Acidic hydration of alkene. When it is concentrated sulfuric acid, that do dehydration. But when it is dilute H2SO4, that do hydration. So we having three methyl butene treated with H3O positive. That is H2SO4 dilute. Yes or no? So what will happen is, what is the mechanistic approaches? That in the beginning, the H positive of the acid we know the reaction of alkene, the nature is electrophilic addition. तो जैसे ही ये पाई बॉन्ड शिफ्ट हुआ CH3 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 and we will get secondary carbocation. This secondary carbocation then undergo a rearrangement, and this undergo a rearrangement by hydride shift. That is, we having hydrogen here. This hydrogen from here will be shifted to this, and instead of secondary carbocation we will get tertiary carbocation. This is similar to as we used to do SN1 reactions. वहाँ substitution होता था, यहाँ addition होना है, and we know that the nucleophile here is water. So this H2SO4 who get converted into H positive, and that is what is hydronium in aqueous media, and we get this HSO4 negative. So right now you are thinking that why this HSO4 negative do not attack over that carbocation. We know it from very beginning that this is a non-nucleophile, as this is the conjugate base of the strongest acid, is a very weak base. I get it. It means in this case we should say that this water will attack on the carbon, and we will be getting this CH3 C CH3 O H H, where oxygen is trivalent and is with positive charge. And in the meantime, it is HSO4 negative जो मांग रहा है मेरा H पॉजिटिव वापस दो. जैसे ही हमने उसका H पॉजिटिव वापस दिया, we got it CH3 C OH CH3, that is the rearranged product whose name is 2-methyl butane 2-ol, and that catalyst H2SO4 is generated. So as we expected secondary alcohol, but our product was tertiary alcohol. So it means the characteristic of this reaction is characteristic of reaction is that this undergo the rearrangement of the carbocation form. Am I right? So one is that this will undergo rearrangement if there is any possibility. And the second is characteristic is that it will follow Markovnikov's rule. क्योंकि हमने हाइड्रेशन आगे भी करनी है, तो हमें कहना चाहिए कि दो बातें हैं इस रिएक्शन में. एक बात यह है कि भाई यहाँ कार्बोकेटाइन रीअरेंज होगा, और दूसरी बात इंपॉर्टेंट बात यह है कि यहाँ मार्कोनिकॉफ रूल फॉलो होगा. आप देख लें, the negative part of the adding species goes to the carbon with less number of hydrogen. It means जब भी कभी आप इस तरह की प्रॉब्लम में फंसोगे, then these two things they will take you out. बात नंबर next. Oxidation in shortcut is called HBO, and in this HBO, what is going to happen? Let us see. It means let us do the same, let us take the same reactant. CH3 हाइड्रोबोरेशन ऑक्सीडेशन. हमने इसको ट्रीट कर दिया B2H6 half B2H6 के साथ. Half B2H6 is nothing but it is BH3. When it is BH3, it is boron hydride. And boron hydride means H की तरफ bond shift होगा. And we know that this CH2 will become negative and CH will become positive. Clearly means that this CH will be attacked by this H negative. Yes or no? So ये H negative वो CH positive पर अटैक कर देता है. We got CH2 and hence we got this as BHH. Yes or no? From where I can say that still I need 2 moles 2 moles of A. Who is A here? This is A. इसके 2 मोल मुझे क्यों चाहिए? क्योंकि मेरे पास 2 हाइड्रोजन है। जब मैंने इसको 2 मोल A के दिए, so what I got is, that is trialkyl borane, and there is no possibility of what? Rearrangement. There is no possibility of rearrangement, and I got it trialkyl borane. This trialkyl borane having carbon metal bond. Which means this is what? Hydroboration. हो गया हाइड्रोबोरेशन। और हाइड्रोबोरेशन के बाद है ऑक्सीडेशन। इसका मतलब कार्बन मेटल बॉन्ड टूट गया। जब कार्बन मेटल बॉन्ड टूटा, so we got this वो टूट गया। जहां से टूटा वहां हाइड्रोक्साइड आ गया, और जो बोरोन है उसका बन गया बोरिक एसिड। तो हमें 3 मोल हाइड्रोक्साइड के मिले। 3 H यहां है, 3 H यहां है, 6। इसका मतलब 3 मोल H2O2 से ऐसा हुआ। यहां देखें तो हमें जो कुछ मिला है, दैट इज एंटी टू द Marconi-Kops. So we should say that in HBO there is anti-Marconi-Kops. There is anti-Marconi-Kops. जिसमें रीअरेंजमेंट का तो कोई मतलब नहीं होता है। इसलिए जो आपने घर से करके लाना है वो है इस रिएक्शन को सारे रिएजेंट के साथ करना है, and see what is the difference in the product. One is do it with H3O positive. Second, do it with OMDM, OMDM, oxymercuration, demercuration. What is the product formed because of this reaction? Difference in the product we have already done. What is the product formed when it will be HBO reaction. तो आपने इन तीनों रिएक्शन के मैकेनिज्म करने हैं, क्या प्रोडक्ट हुआ वो बताना है, इनकी कैरेक्टरिस्टिक्स मैंने बता दिया आपको क्या करना है. सो थैंक यू वेरी मच, हैव नाइस टाइम.